Welcome back. This session is part of the Lakeflow Spark Declarative Pipeline sessions, which I've been running for the last three sessions. And today is going to be a third session on those series, and it's going to be about materialized views. So we covered before like streaming tables was yesterday, and then introduction to Lakeflow as well. So we made like a general introduction to Lakeflow, the new, and we saw what was new in that area. And then we jumped to streaming tables. And today we are going to see materialized view, which is used in silver and gold medallion architecture structure. That's what we are following. Now, the outcome of this session would be is like I would be happy if you come out from this session understanding how to use, when to use materialized view with streaming tables. Yeah? And the second outcome I want from this session is engine managed refresh strategies. Yeah, especially we are going to talk about the specifically on the silver layer. There is like the materialized view, which is powered by the enzyme engine, I think. So we are going to look at that one as well, and I want you to understand what these engine managed refresh strategies are, and then we see try to understand the complex transformation and the aggregation which we do in the silver and gold layer. And the fourth outcome I want you to understand is join patterns and window functions as well. I want you to understand this too, because that's crucial when we do data engineering, and especially in the transformation side to that one. So also we will do like performance optimization as well in the silver and gold layer. Now let us start on this materialized this streaming table decision. Now, if you see the first input, I was saying for the last couple of sessions now, we have moved from DLT to PySpark. Databricks have now moving from this proprietary DLT to the open source PySpark. And that's what we are, from that PySpark, we're importing the pipeline as a declarative pipeline, as it were. So this is the new one here. The rest like PySpark SQL function and PySpark SQL window. I think the window is new as well. But if you were using like Materialized View before, and when using like PySpark SQL, I think the window will be clear to you as well. Now let us see how do we create this materialized view. Yeah. Now we have this decorator like DP, which is declarative pipeline, and we say dot materialized view decorator. So this one, this material view is like for aggregation. We help us to do aggregation, joins, and derive logics. This is one of the function of this materialized view: aggregation, joins, and derive logic. And also, engine decides full refresh with incremental update. Yeah. So this is also another feature of this materialized view. So we have this enzyme. It's called enzyme engine, which will help us like refresh the materialized view, whether to decide whether full refresh and incremental update. Yeah, and then you have this standard batch resyntax, as well as ideal for silver and gold layer. Now, let me just explain a little bit about this materialized view, even though I've done it in different sessions, but I'm going to repeat now. Probably it might help to understand with what is materialized view. So a view, as we know it in SQL, it is like a query. So you have a table and you want to query that table and you create a view. And when you create that one, when you execute that view, um, the what happens is like you have a data which comes from the table. Yeah. When you finish with that view, there is no data at all. So the table is like the key part, and the view is like just we are querying the table and seeing the data, the result of the queue. So we call the result of the view of the normal view is not materialized. It's not in a storage. We don't store it anywhere. Yeah. So that's one. But when you say materialized view, now the view which we are creating, the query which we are creating, now we want to store it in storage in a table. Yeah. So that's again, this is clear distinction. This is what we call materialized view. The query which we wrote, the result of the query is going to be saved in storage. This is number one. Yeah. Now, once you save it, though, how is going to be update or from the table? So there is a table there, and you have this query. The result is now saved into a storage. But what happens if the table change? If there's an update, insert, whatever on the source table. Now this is where we call we need to refresh, refresh the materialized view. So for that purpose, we there is an engine. It's called enzyme engine. We support that refresh from the table to materialized view in Databricks. Yeah. So now what happens? For example, the change might be a small change or big change. Meaning, say for example, a couple of data has been changed, but the majority of the table is there. So do we need to refresh the whole table, or can we just refresh this small part of it? Or if there is major change, for example, on the table, so this incremental update is good or bad? So what happens is like if it is this enzyme engine will help us do the refresh. If it is small change, then it will be an incremental update for the materialized view, and but if there's big change, it will be a full refresh. Yeah. So this is what we call this engine decides what happens for the whether it is full refresh or incremental update. Now, because the query, it will be like this will be an aggregation, joins, and derived logic within that query. This and then the result we said is stored in data, and then when we want to update, this engine is supporting us. So the data will be fresh, yeah, as update which happens on the table will be reflected on the materials view, and also the performance will be great because this aggregation and joins, of course, requires time to run them, and because the result we are saving and then we are updating it, so it will be easier for the user just to see the data because it is like a materialized data, or the query is saved there, the result of the query result, and therefore it will be easier for users just as if they are looking at the table. So again, this is the advantage you can get from this materialized view. And because the support is for aggregation, joins, and derived logic, and most of this functionality is done in silver and also in gold, and therefore it will be appropriate, ideal for silver and gold. Yeah. Now, now let us see what is happening here when we say materialized view as a decorator. Yeah? So we have, for example, this is our function, silver function here. As we said, there will be like this is a decorator here, the materialized view. We are decorating with materialized view with this functionality, the one we said before, support for aggregation, and then this engine deciding for refresh this and the incremental update. And it is that is what we are bringing here for this function. And then what we are doing is like this is like quotes, three quotes. It's within the three quotes here. So this one we are telling the Databricks that we are giving information about this function. So what we are saying is like it is transformation from bronze to silver. So, and the key operation here is like read from bronze layer. First, you need to read the bronze layer, and then what you do is like filter out invalid records. This is we are doing cleaning up. Remember, the silver is for clean up, so we are doing filter out the invalid records and also deduplicate. Yeah, if there is a duplicate record, also just take one which is the one which is active, and then a standardized format. And then we are also doing the format, for example, the date the data type. Yeah, we are going to have a specific, for example, if you want like instead of the date of the string, we want to convert it to date or to decimal to integer. Yeah, casting we call it. We will also cast in, and also if we need like everything lowercase or uppercase, yeah, we are going to do that one as well. So this is like standardizes and then add derived columns as well, yeah, to make it to make it rich. So that is what is going to happen on this is what's going to do this function. Yeah, now it is going to return this again. This is now is read. It's not like stream, read stream. It's read from a table. We can also do, for example, from stream, because remember the bronze is like a stream table. Yeah, so we can also do it that way as well. But let us do it like let us make life easy here. So let us read from the table from the bronze customer here, and then we if the customer the email filter out if the email is not null. Anything which is null is like be removed from here, and then we are saying also if the email is not doesn't form like a specific format, then we don't want it as well. So just we need to filter these two. So the email is important here, email customer, because we are going to communicate with customer, and it shouldn't be null or is formatted in a different way. So we are just checking here, and then if it's not formatted properly, then we are filtering it out, and we are just taking the clean data here, yeah, and then do duplication as well. Drop duplicates for customer ID. If there is duplicate customer, also we need to remove it. We can do more than that, but just this is we are just showing here what this materialized we can do, what you can do here in a very easy way to understand. Yeah, so we are selecting customer ID, first name, last name, and then we are doing the lowercase for email, for example, and then we are aliasing email, and then we are doing upper country is in upper, and then for example, and we are aliasing the column name is as a country, and then we are doing created at as well. So that is what we are doing in silver, cleaning up silver, of course. Yeah, and now let us see how do we do the aggregation on the gold layer here. Now for the gold layer, we're going to go a little bit further. We are going to aggregate data by day. By the way, the silver layer is not aggregated, as we see. It's just clean, and therefore to be appropriate for people who do analysis or data scientists. So this is like because it's record by record. Yeah, there is no aggregation. It is not like, for example, KPIs, for example. Yeah, it's not for KPI purposes. The gold one is we use it for KPI and decision making process in terms of the business. Yeah, so just this one is for business, and this one is like for further work within the business. Yeah, now for the again we are just bringing the materialized view. As you can see here, we are adding this extra like metadata. We are saying daily sales summary. Yeah, so this is we are just adding this information in the Unity catalog. Yeah, so also in here, what we are doing is like we're just giving more information about this aggregate sales. It is data by day, just what we are doing by day now. It's not by month or year. It is by day. And then what we are doing is the metrics we are going to use is total transaction, total revenue, and average order value and the unique customers. Yeah, so we are going to find all this information from that table. Yeah, and if you can see here, you see again we are going to return linking into silver and group by because we are going to do by day. Remember that this is a key part, day here. So the date is being first grouped by to date, yeah, column, and then we are aliasing it to day here. So we are converting, remember, converting it as well, yeah, casting as well, yeah, casting it first and then grouping by that date, yeah, and then we are aggregating count, sales ID, and we are calling this the count of sales ID as total transaction, yeah, and we are summing the amount as this one also total revenue, and the average is average order value, yeah, and count distinct customer is like a unique customer, yeah, and then we are ordering by date, if you can see here. Now, what about if you want to join multiple tables? Yeah, so this is also will show us joining multiple tables here. Now, in this example, which is slightly different from the previous one, so we are just is going to be a little bit more complex as we go along. We saw the simple version, yeah. Now we are doing like multiple tables, and in here, this is very straightforward. As you can see, just group by, and then just count sum, average, count distinct. There is nothing like fancy here. There is no Windows function. There is nothing which shows you like there is the advanced function being used. Now a little bit advanced here. We are joining multiple tables, yeah, and the purpose here is to create enriched dataset by combining multiple sources. Yeah, like we call it sometimes integration. This one, yeah, there's another name for it. If you start like combining 2, 3, 4 tables to create one table, we call it integration as well. So there is also a different kind of integration methodology. We are going to make it as simple as possible here. Yeah, so join sales with customer now and product dimension. So we are joining the sales now, customer and product, two tables, and then the join strategy is inner join, ensures referential integrity, and then select relevant column from each table, and then rename ambiguous columns as well. Yeah. So we are reading from again. Don't forget this is a declarative one. It's not the normal one. So in the normal one you need to say one by one. You need to give instruction, as we say, or as we said before, this after this after this, and then you need to write the end result. But this is not like that. Just we are giving our wish list, as it were. Like we say we want this, and then Databricks is going to figure out how it is going to be done. So just here we are just putting the sales variables, as it were. So reading from a table called bronze, reading from a table called silver customer, reading from a table called silver product, yeah, and then we return sales, which is join the customer, yeah. It's going to be, we are going to take customer ID, which is going to be inner join, and then we are going to join with products, yeah. So again, we are going to say inner join as well. So what we are doing here is like we are going to select like sales ID, sales date, amount, and customer ID. We are concatenating here. Concat means concatenating customer first name, and then we are just if there is no middle name, yeah, we just is going to be like empty. If there is a middle name, it's going to be added, and then customer last name, and we are going to elicit like customer name. This is another useful technique you can use here, yeah. And then in here is the country, aliases with country underscore customer country, because country could be different kind, but you are talking about customer we are talking about the customer country here, product ID and product name and product category. That is where we are taking. Yeah. Now, this is how we join these two tables. It is inner join, as it were. Yeah. We're joining sales. Don't forget, we are joining sales here. Remember, this is sales here. Yeah. So sales, sales, there's customer ID there. So customer with customer ID, sales with also with product as well. So that is what we are doing here. We inner join, and then that's what we are taking out of that the three tables. We are just selecting these ones. Yeah, just we are formatting this one. Don't forget concatenating to find customer name or full name. They call it. Yeah. Now this is a now it become a little bit complicated now. You just bear with me because now we're getting into heavy stuff like window functions and so on. Yeah, adding to different tables. So this is the advanced analytics with window function. Now calculate running totals, ranking, and time series analytics. Yeah, it's very important. So how do you do running totals, ranking, and time series analytics? Yeah, so that we're going to do. This is mainly for gold. In the gold, that's what we do normally. So we make it ready. The data, we make it ready for analytics, yeah, or for reporting. Now we are going to calculate, of course, customer lifetime value and purchase pattern. So that is our aim here for this gold set. We want to know the customer lifetime value and what the purchase pattern as well. Yeah. So we are going to use window function running total of purchase, and we are going to do customer rank by spend, and then days since last purchase the customer. Yeah. So we are going to do these three. Now the window function is now, if you are familiar with how to do things, even in different data platform, the key part is in window is like the partition, you partition and order by. So these two are very important. You partition your table, and then you order those partitions as well. So these two are very important. Now, because we use them again and again, you can call them like, of course, you put them into over. This is the key part is like there's an over function. You put those ones, and then you have the one we call Windows function. Yeah, the window function, and then because they have a specific format, the format is like over. Within the over function, you put your partitioned by and ordered by. Yeah. Now, what we are doing here is like instead of just writing again and again, we are putting the partitioned by and ordered by together as a window. This is again a standard way. You say you use always window dot the partition by, and then the orders by, and then you give it like as a variable, yeah, to reuse it again and again. Yeah. Now this is what you are doing here, yeah, to reuse this one, because it is that's what we are going to use again and again in the over side. Yeah, so whenever you use over, yeah, we will do that kind of we are going to use this one. Now we are going to read the sales enriched, which is you remember we have done sales enriched one, this one. So we have enriched our table with this as you can see here. So we have this specific, we have chosen this specific columns from the sales one. Now we are using that one in here, and then we are adding a column called cumulative spend. Yeah. So we are going to sum all. Yeah, we are going to sum the amount which is in here. We just can you see this one, the sales amount here. Yeah. We are going to sum then, because don't forget what you have done here is we're combining inner join. So there is not just is like a pure. If there is a customer ID, if there is product ID, is going to pick it up. If there is nothing there, it's not going to be picked. So the sales which are for this customer and product is going to be picked. Don't forget this one and we have the amount for it now, of course. And this is because of the inner join. Yeah. So here we are just cumulative spend, the spend, which is the amount. And then we are using this over, as I said before. This is what we are doing is like we are partitioning by ID, customer ID, and ordering them by sales date. Yeah, that's what is happening. So this one, we are summing all of them cumulatively. So this is the column we are adding. So we are also adding another column. We call it purchase number. Again, this is row number. This is a window function. We are using row number here. Row number is just what it does is like it gives a sequence, yeah, for your rows. So if you have used row number, so if there is no, say for example, if there is no primary key, you can use the sequence of row number. You should use row number, you partitions, of course, and then you order it, and then they say row number, which gives you the sequence of numbers. So here we are using the same thing, row number over this is over function, which is again we are using this customer ID. We are partitioned by customer ID and sales date. Yeah. So again, this is the over and the row number, which is going to give us the purchase number. Yeah. Now, again, we when we do this kind of thing, we shouldn't. We always need to think about this table. Yeah, the sales table, which we have done inner join for customer and product ID. Yeah? So the sales table with this ID now is like the purchasing, or what we purchased. Yeah, what had been sold. In this case, we are calling it purchase, and we are ordering that one. Yeah, so that is a purchase order, which we are doing in the previous one. Yeah, so we have done the purchase number. Yeah, and then again days in its previous purchase. Yeah, so for that one we are using date diff. Yeah, the difference between two dates. Yeah, so you have the sale data. Now this is very interesting as well. Lag is again another function which is very useful. What happens, like for example, if you want to say the difference between if you have a column of sales, for example. Yeah? So all column for today and for tomorrow, for example, you have these two. Yeah. So if you want to see the difference between the two rows, yeah, there are two rows. So if you want to see the difference, you need to say, for example, today and tomorrow. So or yesterday, for example, you have a sales from yesterday and today. Yeah. So if you want to subtract, for example, today from yesterday, that's what you do, right? So if you have a list of them, for example, a lot of customers there, which they have purchased today and yesterday, and today and yesterday, and so on, yeah, all of them. So you want to make the difference. So first, what you need to do is like you need to use this lag function, which will do you create another column. So so for example, if you have yesterday and today, it will give you like the order which was on that date, lagging one behind. Yeah. So, for example, what happens is like the yesterday one, yeah, will be like with the today. You have we have two rows. One row will have today and the same yesterday. So we are bringing from the column number one, yeah, yesterday, yeah, and you're putting it another column, and of course there is a today column as well. So they will be face to face, as it were, yeah. So you have today and yesterday, two columns, today and yesterday, and then it will be easier for you, for example, to subtract or to add, to compare these two, yeah. It's say yesterday and today. So that is a lag function. I hope I make it clear, but you can read about it in Databricks as well. They have a very good documentation with this regard. So this is the lag. So they are using the lag, yeah. So there is sales date, yeah. So there is two sales date, up and down, and then yeah, they want the difference. The difference here is the date difference, they creating a column. You have a sales date, and then using the lag, you are creating another column. But you are bringing this column. You want to bring like yesterday and today side by side. Yeah, that's what it gives you the lag, and then it will be easier to do the difference between the two. And once you do that one, and then you are doing this. You are doing this over. Yeah, you are using it like this. You partition it by ID and order ID. Yeah, so that's what is going to give you days since previous purchase. Yeah, I hope make sense to this one. The lag function is very useful window function as well. So we have used this one, the lag function here. So and then you just after that you need to select what you want here. So ID, customer name, sales amount. Then this is the one you have already calculated, as it were. Yeah. So you have these three. Now I hope makes sense for you here. So now another one is you can also apply complex business logic and calculation here. So implementing business rules here. So for example, you want to say, for example, the VIP, recent, frequent, high value customers. Yeah. So you can segment the customers in these terms. Yeah. He's a recent customer. He's a frequent customer. He's high value customer. Yeah. And then you can say, for example, it's moderate activity. You will say at risk, for example, not purchased recently at all, which means this is at risk. You can say it's dormant, inactive for a very extended period of time. So you want to do this kind of course of data, which is a very complex business logic and calculation. You can also do it using the Windows function as well. Yeah. So you can do it here, and I have chosen a couple of them here. I hope it makes sense to you as well. Now, what you are doing here is, again, we are taking the cells, the silver cells, enriched one, yeah, and to do like now we are grouping by customer ID and customer name, and we are aggregating it like max sales date, yeah, last purchase date, and then we are counting the sales ID, purchase count, and then we are also doing the sum, yeah. So we are doing this one. This is a customer summary. So we are grouping it according to this one. So you'll have this data. Now, from this data, what you want is like now we have customer summary. We are going to add to that days since purchase. Yeah. Again, this is another one, another date difference, lead today, and then last purchase. You know, this we have done this one before. This one will give you the days since purchase. Yeah, and then you have going to add that you are going to segment it. So when the column days since purchase is less than or equal to 30, and the column purchase count is greater than 5, and column total spend is greater than 1,000, call them VIP. Yeah, can you see here now? So what we have done is days since purchase, we have calculated using this formula, and then purchase count, we have done it somewhere. Purchase count is here. Yeah, so we have done this count of sales ID, this purchase count. Yeah, and then the total spend as well is here. What you are doing is we are summing sums here, but don't forget we are doing grouping here because customer ID and customer name. Yeah, grouping these two together. Yeah, by this, and then we are doing the sum here, and then this one will, and then we are saying here, if this sum is, if this total spend is greater than 1,000, then we are going to call them like a VIP. Yeah, and then the days since purchase is less than 60, or less or equal to 60, and then the purchase count, if they only come to us 3 times greater than 3 or equal 3 purchase count. Yeah, but it was spread in 6 days. That was in 30 days. This is in 6 days. And then if they and then the purchase is less than 100 pounds, for example. Yeah, we will call this one at risk. Yeah, this is business. It should be like this. These rules should be like coming from the business. Yeah, business logic. It is not you who decided which is which, and the business will decide what they want. You are going to give them like the technical solution. So this is what they tell you. If this is the person, they call him VIP, and you are doing this technical solution for them. So this one is coming from the business requirement, as it were. Yeah, it is not you who decide which is which as a data engineer. So that's not your business to do like this total spend is this or count it this. This the business will understand it. They would know it better. You are very good at creating, transforming, converting their requirement into technical solution, and that's what you are doing here. Yeah. So again, sorry, this is regular. You call it regular, but if they haven't purchased, like the purchasing is like less than 100 days, for example, they're at risk. Otherwise, it's dormant. So you have this 100 mark date. So if someone came after 100 days, it's almost dormant. Yeah. So that is the requirement, and that's what you are adding here. Yeah. The key parts to say is this logical, the logical, um, um, the logic here. Yeah. So we started from. Don't forget, we start from the joining the tables here. Yeah, we join the table. We've chosen the one which is required here, the columns we need from them. We have done some kind of concatenation here, and then we have done a little bit more than that, and then we have done this cumulative spend. Yeah, and then you have this implement business rules here. We are doing these business rules. Yeah, these complex business rules. Yeah, so now this is one, and then we are selecting this one. Yeah. Now this is one part, the business complex. Now let us see if they want rolling windows and time series. Yeah, you want to forecast, for example, what is going to happen in the future. But for that one, you need the rolling windows. Yeah, you need to cumulative one. So what you want is like a 7-day rolling average. You want to have a rolling average every 7 days. That is the key part here. And then the 7-day metrics here. So the 7-day moving average revenue, week over week growth, what is happening every week. Yeah, but you need to do like a 7-day moving average. You need to have an average of the week, and therefore you can compare week over week, and then the trend indicator as well. Yeah, so from there you will have a trend indicator. This is what is going to do in this gold layer functionality, and this is again, it is a business driven. Yeah, it is a business who decide what they want, and then, as I said before, you are just putting a solution for them, technical solution. Now, to do the window rolling, you need to have the first 7-day. So how do you do it? For the 7-day, first you need to order by date, and rows between. So you start from 0 always, and then you go the opposite direction. Yeah. If you are today, for example, you want 7 days from today back. You need to count back. Like if today is like Sunday, yeah, you need to go back until Saturday, right? Yeah. So you need to start from 0 to -6, as it were. That's what you are going to do. So you are ordering date based on this. So you will have this will have a week 7-day, window 7-day. Yeah, the window for each 7-day. So you will have a window of 7, 7, 7, 7, 7 each, and then it is easier to compare these 7-day windows. Yeah. So we have this variable now, and then you have the daily one is gold daily sales. Yeah. Again, we have done it before this one. the gold sales before, so we are reading it from there. Yeah, so I think if I've not forgotten, this is the gold. We are silver. Yeah, this is the one. Can you see this one? This is the first table we created. Yeah, the simplest one. It has only total transaction, total revenue, average order, and so on. Yeah, there is no much work here. There's no Windows function, but it is called daily one. So that is what we are using here in the rolling one. So you have these two, daily and window is 7-day window. You have these two, and we are using this daily, and then we are adding to that one, to that table, a column. We are calling this revenue for 7 days. Yeah, so we are doing the average of total revenue over this one. So you are just averaging these 7 ones. Yeah, so you are just using that the total revenue from this table. Remember, this table now daily is coming from gold daily sales. Yeah, so we are doing this 7 average. We are going to call it revenue within the 7-day window. And then you are going to have another one, revenue 7 day ago, which is lag. Again, the lag is going to create another column side by side. Yeah. So revenue, for example, of today, of this week, is going to compare it with last week. Yeah. So we'll have this on the table. It will be one after the other, right? On one table. But what you want to do is, because we want to compare them, instead of just going on that table and going back and forward, what you are doing is that we are creating another column to show us the previous one. Yeah. So if you are talking this week, we want like last week, and what we are doing here is by creating a column, we are bringing this week and last week side by side, and it will be easier to do some arithmetic on it, right? So that's what we are doing with the lag function. Before, it's not changing here, just only we are using here the total revenue instead of date. Yeah. So this is, again, for this lag, what we are doing is 7 days. That's what you are doing. So you are taking the 7 days lag together. So every 7 days, the previous 7 days, and creating a column, and then doing the it is over this. We are using this window function. Yeah, we are ordering by date. Yeah, so that is, again, it will give you revenue 7 day ago. This is a column here, and then what you're doing here is like week over week growth. Now we are going to do like total revenue, yeah, minus the revenue 7 days, and you are going to divide it by revenue 7 days ago, yeah, times 100. So this will give you the week over week growth. Yeah, I think probably if you are just um, again, if you are building one by one, you will understand it. So the key part here is probably, if you go to, and if you don't understand the lag, then it will not make sense for you, because the lag is the key here. Yeah. So you need to understand how the lag operates, the lag function, and if you understand it, it will be easier. So the key part is the lag will make two columns. It will create a new column, but that new column will be dependent on the other column. But what it does is like it will take the previous, for example, if it's today, the previous one yesterday. If it's this week, the previous week is like last week. Yeah, so something like that, and then it will be on two face to face, and it will be easier to do this arithmetic here. Yeah. So as you can see here, for example, you have done total revenue, and then we are subtracting the revenue 7 days ago. Yeah, and then we are just dividing it by 7 days ago as well. So times 100 to give you week over week growth. Again, this is a standard. How do you make growth? So you have revenue time minus, the growth is like the percentage. You need to have two things. Yeah. So you have a 7 day ago revenue, and then you have a total revenue. You subtract, and then you divide it by the 7-day revenue, and then times 100, it will give you growth. Yeah. Now this is again, I think if you have done some kind of I don't know, business or accounting or something like finance, it will be clear, I think. So if you don't get it here, probably it is good idea to see how this finance or accounting deal with growth. What is their formula for that? It's coming from those fields. This one, yeah. It is not your data engineering field, but we just data engineering, they are using it, and here as a solution. So you can ask the business here, but how do they do growth? They will give it to you happily, and therefore just convert it here as a technical solution and try to understand what is happening. This minus this over this one. Yeah. Now the trend is a bit interesting here. Yeah. So so you are saying here week over, you see, over week growth. Yeah, this is what we have done here, week over week growth. So if it is greater than 10, there is strong growth. Yeah, and if it is greater than 10, moderate growth, and if it is greater than minus 10, is a slight decline. Yeah, otherwise it's significant decline. So that is the trend you are calculating. Yeah. Now this is again. There's a couple of things here: the Windows function, the rollings window, the time series, those ones, and also a couple of aggregations together. It's just you see how powerful they are to solve business needs or business requirement. So in Databricks here in our case, Lakeflow is giving us the materialized view to do all this stuff in one place. Yeah, and the materialized view is, this is like a query, and the result of this complicated query is going to be saved into a storage. This is what giving us this declarative pipeline. That at the end of the day, we are saying this is what you want, and behind the scene, all this work is going to be done, and is going to be converted in materialized view. It will be saved in storage, and then this enzyme, we call it, it will kick off, and what it's going to do is like is going to do the refresh, whether it is full refresh or incremental refresh. Yeah. So if there is slight change here, as you can see, it's very complicated mathematics here, or functions, which requires a bit of time to finish, and therefore it need to be. It is so difficult for a user to ask for something and then to wait probably half an hour or an hour until all this function is finished. Yeah. So what is happening is it is going to be run once and it's going to be saved there. So it doesn't need to run again and again when a business need, when a person needs, or the business needs the data. Yeah. So the data will be there, the outcome will be there, and then it will be refreshed every now and then by this enzyme um, um, engine. So this is what Databricks is giving us in here. As you said, materialized view. You can use it for gold. You can use it for silver. You can manipulate or do something on the data. Yeah, and then it will be saved in storage and also updated frequently. Yeah. So we saw the declarative one, how it works here in the silver and gold. And now let us see what is best practice, yeah, in materialized view. Now, one is like use a standard Spark read table for batch processing. That's another one. Instead of using the stream here, it is better to use the standard Spark.read table for this batch processing. Leverage engine's smart refresh decisions, and then use explicit column selection. Avoid select all. Yeah. So again, if you see, what we are doing is like we're selecting the column you want. We are not saying all columns, because it is demanding, costly, and also error prone. So you need to avoid select star. Yeah, you need to choose your columns carefully. Now the cache intermediate results for complex logic. Again, this is as we saw, some logic are very complicated, and it is better to do them in a separate on a separate line, so that to help you like to cache them separately as well, so that you don't need to redo them again and again. But again, as I said before, because we are putting them in Materialized View, it will be refreshed by this enzyme engine. Now apply filters only early in transformation chain. Again, this is very important as well. So you say it could be big data, and then when you you build your query here, so the one which requires filtering, you do them earlier, so that when you do this complex windowing or complex analytical data, it will do it as easy as possible. It will work on less data, and therefore will be quicker as well for you. Yeah. So use broadcast joins for small dimensional tables. I think this is a bit again, this is very important. Yeah, you need to understand what the broadcast joins are as a data engineer for small tables. I'm not going to talk about it now, but it is good to know that it is good to use the broadcast joins. And if you can just dig in, try to find out what broadcast join is good. It will help you as well in your work. So what you shouldn't do is, use streaming radius in Materialized View. So try to avoid streaming radius because it costs money for it doesn't add anything for you, right? If you think about it, the streaming in this case, it doesn't add any value. There is nothing. You have a table, a streaming table already. You created those ones, so you don't need to create like another streaming, which costs you more money, right? Now also you shouldn't use this. You shouldn't call .collect .count inside definitions. Again, this is also, we saw it in bronze. You need to avoid this kind of in the definition .count or .collect. Yeah, when you do the definition in the silver or bronze. Yeah. Now don't mix again streaming and batch reads as well in here. So just do the mixing is not good. Yeah, if you start batching, you need to do batch read. And again, do not create like circular dependencies between views. Yeah, this again, you need to be careful because these views, when you create them, as you can see, step by step, without realizing, it might be like you might do dependency, circular dependency, which goes again and again, and also it is not good for costing. It will cost you money, as well as it will fail eventually. It will tell you that this is a circular view, and therefore it isn't going to run it at one stage. So you spend your time, your money, but you don't get results. So avoid it from earlier. So for this purpose, you need to have a specific plan your views beforehand and see which one is going to depend to which one before you implement it. Before you write the views, you need to plan them, and you need to understand which view will be depending on which view. Yeah. So don't forget to optimize join order as well. Yeah. This is a standard one. So just always the join order is a key part. So optimize the join order. Now, again, a little bit of tips here. So let us see for this the engine. One tip is like engine automatically decides full with incremental refresh. Yeah, that is this engine is the one we said enzyme engine in Databricks will automatically decide full or and incremental refresh. This is one you need to understand this bit as well. You don't need to do a lot of things here. Yeah, but you need to, of course, you need to monitor what is happening, but it will be automatically decided by the engine. Yeah. Now another one is like views update only when upstream data changes. Is straightforward, of course. So all the changes, of course, when you are in the gold layer, so the gold layer is going to be updated when the silver is updated and the bronze is updated. Yeah, that's again very standard way. And then use partition by in Windows function carefully. because again, this is memory intensive one. So when you do the partition by, you need to know which one to partition, which one is. You need to understand this cardinality, yeah, when you do this partitioning, yeah. So this is, you need to be careful here. Consider liquid clustering for large aggregations. So if you have a large one, again, liquid clustering is like the traditional one, the tradition clustering. You partition by this and partition by this. All this stuff is now changed by this liquid clustering, and it is better to start using liquid clustering in Databricks at least. Yeah. So monitor quality plan with explain as well. If you want to this one again, if you do explain, because you have, don't forget, you have just Spark. Spark has this explain to show you what is happening within the query plan, to tell you about the query plan. So when you are working, it is always a good idea to use this explain to see the query plan, and therefore to intervene if there is something wrong there. Yeah. Now, for performance optimization, yeah, if you have, for example, large aggregation, yeah, if you have large aggregation, now you need to use broadcast join for dimension tables. This is number one. As I said before, I'm not going to cover broadcast joins here, but it is better to look at it in a different tab. But probably if you need, I can cover for you what these broadcast joins are and what is the advantage. But if you have very large aggregation, yeah, it is very good to use broadcast joins for dimensional table, lookup tables, for example. Those ones will benefit from these broadcast joins. And then again, we were talking about partition data appropriately. The partition is also is an interesting bit, and it's very important. So you need to partition. We are talking about large aggregation, right? So if there is large aggregation, you immediately think about partitioning, and you need to think on how to do them as well. So enable also adaptive query execution, and use Z order clustering on common filters. Yeah. So again, this Z Z order clustering is like proprietary. I think, I don't know, Databricks, but in a different platform, it is created by that data platform owner or provider, and they have their own way of doing it. So again, this is a performance idea. So you need to use Z order clustering on common filters. Yeah, yeah. For complex join, what you need to do is like filter before joining. Yeah, always. Of course, this is very common sense. Yeah, you need to filter before joining. Join on indexed column when possible, if there is an index there. Broadcast small tables. Small tables here is like less than 10 gig. Yeah, consider bucketing for repeated joins as well. Now, this is I thought it was a little bit longer than I thought, and I hope you are enjoying this session. And I can do some of them as a separate session, because it's complicated as it is now. We covered the Windows function and how to do the aggregation as well, the materialized view within this context, and now we are talking about optimization, and we are just talking about partitioning. We are talking about Z order. We're talking about broadcast. Yeah. So broadcast joins and so on and so forth. So all these stuff also are new. So we cannot just cover all of them in one. So I think is enough for today. Thank you for listening. And if you feel that you have gained something out of it, don't forget to subscribe and put your comment as well. And if you want me to do something as well, just if you put it in the comment, I can cover it for you as a session. We might get it shorter. It's not going to be longer like this one, but I will promise I will do that as well. So next time we are going to do, next session is going to be about data quality expectation, and it's going to be interesting, and therefore see you on data quality expectation. Thank you for listening.